Okay. Alright, first, here's what I like you to do. This will kind of tie in what we did yesterday. It'll tie into what we did the day before. What I like your groups to do is try to figure out the possible rational roots on this problem. It's very similar to what you had to do in your homework that I assigned you yesterday. You had 5 problems in your homework. Or maybe it might have been 6, but what you have to do is find potential rational roots. Once you find one of them that works, we're going to divide it out and we're going to find the rest of them. But right now, all I need is just what are the potentials. You don't even need to check which ones work. What are the potentials? Okay? I'll give you a little bit of time there. I'll give you a couple minutes here. Let's see what you have. We have 2 or 3 of these today. They're going to kind of mix in our new stuff with this, and I'll explain as we go. Because again, we have one last thing we have to throw in here, and hopefully this will all make sense, and we'll be done today, and you'll have time to work on your 5 or 6 problems that we had yesterday. So try to find the potentials. It shouldn't take you very long, but list them out. I'm going to ask for them here in a second. I want to give you a little bit of time where you can actually attempt one by yourself. Let's see if we know what we're doing so you're not lost in your homework yet. Okay, and again, you don't need to check them, just all I need is the potentials. Which ones are potential roots, x-intercepts, zeros, whatever you want to call them. This is the first part of your homework that you have today. I tried to pick a smaller number today, so this one made a little more sense than yesterday. So I was picking like 128s and 120s yesterday. I was picking big numbers. Today we're going to go small. Okay. All right. Can somebody fire off? What do we have to do? Last number over the first number. So 40 over the 1. Okay, good. That's your first start. Now what do we have to do? That was a good, great first start. Somebody else now. That was good. Say it again. List out factors. Okay. So let's define, what are factors? That is good. Numbers that multiply together to give you that number. That's exactly what you're doing. You're finding factors of each number. So, what are the factors of the number 1? 1 is the easiest number. If it was any other number, you do have to break that up. So let's say it was, I think one of your problems, one of them is a 2 on the bottom. Because that's the front number, right? Well, it's 2 and 1. So you have to break that up. Now, 40. We have quite a few on 40. Not too many, but we have a few. What is one set? 2 and 20. Okay, I agree with that. That's good. That's good for a set.
1 and 40.
1 and 40. The easiest one possible. 8 and 5. We have, I think, one more. 4 and 10. All right, good. So we have quite a few numbers to check over. Okay, now, to make every combination possible, you take the top, you put it over the bottom. This is the first part of your homework. That's what you have to do to start with. So you take this over the bottom number. So it's going to be plus or minus 2, plus or minus 1, I'm going in no particular order, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, plus or minus 40. Okay, those are all of your combinations. Now, if any of them had, like, let's say like one of your examples I know for sure has a 2 out front, so the bottom number is 2 and 1, you have to make every combination putting the 2 on the bottom as well. So 2 over 2, 20 over 2, 1 over 2, 40 over 2, 8 over 2, but you don't have to put repeats. So like when I said 40 over 2, that's 20, I don't need to put it again. Or 8 over 2, that's 4, we already had 4 listed, I don't need to repeat that one again. 1 over 2 would be a new one, or 5 over 2, you know, so you gotta make every combination that would be possible. Okay, does this make sense with the first part you have to do in your homework? Out of those 5 or 6, I guess.
Yes.
Okay, good.
It said once you find a factor, you put it on the bottom.
Say again?
It said once you find a factor.
Oh, like when you actually like find one that works?
Yeah.
Okay.
This is the 2 over 2.
Oh, like if this was 2 on the bottom?
Oh.
Yeah, yeah, so what I'm saying is like, whatever this bottom number is, you break it up, you might have to make different combinations of top.
Okay, yeah.
Okay, so, did that clear it up?
Yeah.
Okay, good, so, I almost had me confused there for a second. Okay, second thing you have to do in your homework. You do have to find ones that work. So that'll be the top part. You really only have to find one. So you don't need to go find 20 of them. Go find one that works. Always start with small numbers. Try 1, try -1. Try 2, try -2. I'm gonna try the number 2. Okay, I'm gonna start with 2. Okay, this 2 works. So 2. So how do you do this? If I'm gonna try these numbers back to back, now I would be using a calculator to check this out. I'm gonna try the number 2. How I do this is just plug in 2 into all the x's on the original problem. Does that make sense, like how I'm checking that? And I would type that in the calculator, hit enter, and what I'm looking for doesn't give me 0. Because that means it is a 0. It's an x-intercept, it's a root. The x number would be 2, the y number is 0, that's an x-intercept number. That's what I'm looking for, because when you plug it in, it gives you y numbers. So this is 2 to the third power is 8, 2 squared is 4, times 3 is 12, and it's negative. 18 times 2 is 36, and then you add 40 to it. Well, this is 48, this is negative 48, it does make 0. So that is a potential root. So this, boom. So the number 2 definitely works, so check that off. Now what parenthesis represents that? Like what binomial represents the number 2? X minus 2. That's big. You do need to know the parenthesis that represents the number that works. So it's always x, and it's always the opposite of the number, so it's x minus 2 instead of x plus 2. Okay, does everyone understand how I found this thing? This is a big part of today. You do need to find those in that homework. You have to find the ones that work and the parenthesis that represents it. Do we feel comfortable so far? Now, and I warned you, once you find 1, now we go into division. You can go into synthetic division or you can go into long division. So what we're going to do is we're going to go into synthetic. I think this is the easiest, that's what I expect on the homework because it's the fastest way to do it. So what I'm going to do is I'm going to divide out, so since this worked, I'm going to draw a line here, this all worked, this gave me 0, okay, fine and dandy. So now I'm going to divide out the 2 that we know that worked. And this is where synthetic division comes in. So if you find the number that works, put a 2 in the box, that's the number that you found that works. And I'm going to go to the leading coefficients going across the top. What are the leading numbers?
1, -3, -18, and 40.
Boom. And if there's any missing terms, plug in zeros, put them in descending order, rearrange the order, make sure you have negative signs or whatnot. Again, this is the number that you know that works, so one of them. These are the leading coefficients on the original problem, and if there's any missing terms, zeros are filled in for those spots. So this is synthetic division. It will give you the same answer even if you did long division. So if you like long division, let's say that's your go-to, it will still give you the same answer. So let's go through this. So the process for how we actually calculate this. You drop the first number straight down. You multiply by the box. You add straight down. You multiply by the box. You add straight down. You multiply by the box. You add straight down, and this is what you want to have happen. You want a 0 in the back. That's how you know that it worked and you didn't make a mistake. Now, if this isn't giving you 0, even though up here it did, first thing I check, maybe you typed this in wrong. Maybe you forgot parentheses, maybe you typed in the negative sign wrong. I would check that first. That's the easiest thing to check in your calculator. Next, if like you're still not getting 0 here, even though this math told you it was 0, maybe you forgot a negative sign here. Maybe you put them out of order. Maybe you forgot a 0. Maybe you accidentally put the wrong number here. Maybe you put -2 instead of 2. Okay, it could be just little things. Maybe you're just adding wrong. That's what I would make a mistake on. I can't have in my head. Okay, questions so far? Now this should be quick. This should take you a minute maybe per problem to do like that sort of stuff. The hardest part about the assignment, that you know, your 5 or 6 problems you have, is just finding the first number that works. That's the tedious part, you're typing it in, like which one works. And once you find one, then it's just quick. Because now, at this point, this is called the reduced function. It's 1 less power than what that problem is. So this thing will be x squared x, and then plain numbers, and you should have no remainder. So this is x squared minus 1x minus 20, and you don't really need the 1 there. If it's a 1, you just assume it. But this thing should be factorable. If you did it correctly, it should be factorable. There should be another number that works. Now, if it's not factorable, what do you have to do? Quadratic. Yeah, you have to do the quadratic formula to find the other, because they might be decimals. So maybe it's on purpose that you can't factor because it was a decimal or square root. There is a couple times you will have radicals, so just keep that in mind. There'll be a couple that you cannot factor it. But anyway, what we have here, 2 parentheses, is gonna go plus minus, because the minus sign in the back means they're automatically opposites. X and X, and what are the numbers for 20 that I have to break up? It has to be a 1 in the middle, -1.
-5.
Yeah. Yeah, 4 and -5, I agree with that. And the 5 has to be negative, so I need a -1 in the middle. So it looks like my other roots, this was the first one. So again, you should have these listed, right, off somewhere. So x minus 2 was one of the numbers that worked, you already had it listed. X plus 4, and x minus 5. These were all the 3 x-intercepts. This should have potential to have 3, it doesn't have to. Because maybe in the very end, whatever this thing is, maybe it didn't factor apart, or maybe you did the quadratic formula, and it was giving you imaginary numbers, so there's only 1 x-intercept. Questions at all about that? Okay, is everyone comfortable with what you have to do in the homework right now? It's not like overly difficult for anybody. It's just tedious, there's just lots of stuff you have to do there. And I do wanna see that you're actually finding potentials, that you're listing those out. You're finding one that works, you don't have to show me this stuff, but once you find one that works, you're doing this to check for the others, and you're showing me somewhere on your paper that this is your 3 roots. Or if there's only one, tell me what the other mess was that, you know, where it didn't factor apart. Maybe they're imaginary numbers. Okay, but the one thing I want to redo from yesterday, just this one of my, that was the first problem. The second problem I want to talk about is if you didn't choose to synthetic divide, like you didn't like that, maybe that doesn't make any sense to you, you can still long divide. And I want to go through one example. That was the new stuff we did yesterday. Now it may not be new to you, but it was new for this class, right? We're reviewing. So this, you do not have to do this for your homework. This is just something that, you know, I want you to be comfortable with if you choose to, because this method will always work. Synthetic only works in certain cases where the numbers are easy. So if you're going to choose to divide by x minus 2, so let's say you're doing the long division. Like we found 2 worked, right? We found that earlier. And so you made your parenthesis x minus 2. Maybe you just want to long divide it out instead of synthetic divide it. That's how I would do it. Does that make sense? Like how you can do what we did yesterday with this? That's why I was trying to do 2 outs in case you don't like it. So I'll let you take the time to write that down. So, again, this is just a review from yesterday. Hopefully you feel comfortable with some of this stuff. Again, I would not expect you to do this for the homework, but if you did, great. I mean, that you're practicing what you need to know. Okay, so we're gonna have enough time to write it down. What do we have to multiply on an x to make x to the 3rd power? X squared. Where do you put that? It's a 1x squared, right? That's what I have to multiply by. So I'm gonna put it right here, because they have to be lined up with the correct terms that are below it. So x squares are above x, no x squares. So now that I do this, so I'm gonna take this item, this binomial that was on the outside, the divisor, and I'm gonna multiply by the thing we just figured out. Because again, I always wanna make the first item match the first item here. That's how I know what to multiply by. So I'm gonna multiply everything here, this binomial, by x squared, so I get x cubed, and x squared times this is negative 2x squared. Again, how I'm doing that is I'm multiplying the whole divisor on the outside by the x squared. That's how I'm getting that thing that I just wrote down. What do I have to do next? Subtract. You always subtract on division. By subtracting, you're actually just making opposites. You just go through the row, distribute the negative sign through. That's how you subtract. Then you just go straight down. That's 0. This turns out to be negative 1x squared. And you drop down the next item. That's how it automatically works. You always drop down the next one. That's how long division always works. After you subtract, you get your answer. Drop down the next item, and you start all the way over again. So what do we have to multiply on an x to make a negative x squared? Negative x. We're gonna multiply by negative x. If you wanna write negative 1x, so be it, you do that. So we're gonna multiply by negative x onto this thing. So negative x times this is negative 1x squared. Negative x times this is positive 2x. What do we do next? Subtract straight down. Again, the hardest part is just taking the negative x times both of these and remember what the signs were. We subtract straight down. So again, we're gonna change the signs. Go straight down, that makes 0. This makes negative 20. And you bring down the next number by instinct. So that's positive 40. So far so good, like what we've been doing. Now, what do we multiply on an x to make a negative 20x? 20. So we multiply this by negative 20, I'm left with negative 20x. Negative 20 times negative 2 is positive 40. We change the signs, because again, we're adding straight down, so you're changing the signs. You're going straight down, yes, you're getting that goose egg at the end, 0. So we know that it works, it has a remainder of 0. The thing on the top is your final roots, right? So if you chose long division. Now, here's the crazy thing. In the middle of that problem, I was doing this long division stuff, right? You're seeing this. You're seeing all the numbers I was coming up with. Okay? What I mean by that, when you drop down, you had a 1x squared. That's the top. When you were going straight down, you're multiplying, you're going down, you're getting that negative 1x. You're going again, you're getting the negative 20. And that's the top number, right? So this should mimic what you get on the top. But in the middle of that problem, you're starting to see the numbers I was coming up with. 1 and 2. 1 and 2, right? The next part, you're getting the 18, but again, you're going to get a 1 and negative 2 here. You're starting to see like where these things come into play. Eventually you're getting 20 and 40s. Those are coming into place. Like you're starting to see like where, like when you do synthetic, it's actually doing long division. It's just doing it different than you're used to seeing it. All right, questions about synthetic or long division, how they give you the same answer. And that's, the numbers are in that problem. It just looks way different than you'd expect. We're good now? Okay, last thing today. This is my absolute last problem, because I said I only want to do 3 problems. The last thing I want to talk about is what they call the Descartes rule of sign. Descartes rule of sign, maybe you've seen this in Algebra 2. It's a way of predicting your answers before you start. Not like the actual numbers, not like I knew my answer was going to be 2, negative 4, and 5. Not that. What I'm talking about is what potential you have for positive numbers, negative numbers in your final answer for x-intercepts. Or if there's potential that it will have imaginary numbers for your x-intercepts. This thing is not easy. It's one of those things like once you get it, you just know it. It's like riding a bicycle. You've done it enough times, you just can do it. But unless you've tried it or you've seen somebody else do it or you practice it yourself, like you just don't know how it works, and you never experienced the motions of it. Okay? So, anyone still need the long division? Okay. So this will be one of my last problems today. This is something that we might have to talk about a little bit more tomorrow. But today was just kind of introduce it, brand new topic. Hopefully this will click with you. Maybe you've seen this before. Once I get into it, you can tell me if you've seen it, if you haven't or not. I don't know. I don't know what they cover in Algebra 2 anymore. It's been a long time since I've had to teach that, so I try to cover all bases. Okay, so what I do, first thing, I'm going to make this little chart. And this little chart, what this is the possible combinations of roots that you have. So it's not going to give me my answers. This is not what it's for. It's to predict what the answers will potentially be. So it might curb my idea of like, I should only check negative numbers. So it could throw out half the possibilities of what numbers I should check when I was doing that first step. Like, oh, I knew 2 worked, but maybe no positive numbers work on this problem, so you have to check it. So we're gonna look at this, So first thing, you're on this chart, you're gonna have positives, you're gonna have negatives, and you're gonna have imaginaries. Imaginary numbers. And there's three columns, because there's three options you can have for the roots. In each of these rows, we're gonna put numbers. So there's gonna be rows. I don't know how many rows we're gonna need, it depends on, the difficulty of the problem. When you go across, these numbers have to add up, they have to total. When you add up these columns, like these rows here, when you add up the columns, they should add up to be the greatest power. What's my greatest power? 3. So that's how many you should have total. So there should be a total of 3 roots. Does that make sense? So like you shouldn't have combinations like 4s, 5s, and 10s. Like that's adding to be way more than 3. Shouldn't have that. So hopefully that'll make sense, like where I'm coming up with these numbers. They have to add across to make 3 because there can only be 3 roots, potentially. Okay, so what we do for the positive numbers, this first chart, this first column here, what you do is you start on the original problem, and what you do is you count how many times did it start and switch signs from positive to negative and back. Okay, so we're going to start on the problem. So it's a very quick check. So do you agree this first number was positive? It was a 1, right? How many times does it change sign as you bounce like a little bunny across? Okay, so it changed once, correct? That's one change. It went from positive to negative. Did it change again? No. Did it change? Yes. So there's 2. There's 2 changes, right? That means you could have potentially 2 positive numbers that will work. That's what it means. I know it's the weirdest thing in the world when you see it. You're like, what? All you have to do is count how many times it switches from positive to negative or negative to positive throughout the original problem, and that tells you how many positive numbers could potentially work. 2 of them will work. It's the weirdest, stupidest thing you'll ever see, but it actually does work. Now, is it guaranteed? No, because does this problem have to have 3 x-intercepts? No, it doesn't have to, okay? So 2 will potentially work. Now, how you go to the rest of these, because I said there's multiple columns. What you do is you always go down by evens. So what I always do is I always subtract 2's. So if this is a really big number, because maybe your problem switches signs a lot, you subtract 2's. So what would it be if I took 2 and I subtract 2 off? 0. There could be 0 potential positive numbers that work. Potential. Now we already know what my answers are. It was those. But there's potential that it could have 0 positive numbers that work if they were all negatives. That's why I said, like, sometimes you just need to see that, like, there's that potential where there's no positives. I'll try to give you another problem here in a minute without having a similar situation. I'll just write it down. We're not going to actually do the whole round. Okay, we're good on the first step. That's it. Let's take the first step right there. Let's go to the second step. We have to find negatives. So negatives. Now what you do is you plug in negative x's, like it's like we're doing the symmetry test that we did a long time ago when you check how many times, like is it perfectly balanced when you draw the polynomial? You're going to plug in negative x's into all the x's. So plug a negative x in here, because I'm checking negative numbers now, that's why I'm checking this column. Negative x, so that symmetry test actually does check more than just symmetry, like is it balanced like a perfect drawn picture where it's like perfect mirror images, but it also checks how many negative numbers will actually work. So when I cube a negative number, does it stay negative or does it go positive? It stays negative, okay. When I square a negative, what happens? It goes positive, but there's still a negative sign out in front, so that's negative x, or negative 3x squared, because this negative went away because I squared it. Okay? Negative makes positive, and then you have the positive. Okay, so now what we do is we start in the beginning, and you check, starting here, and you do the same bunny leaves, you check how many times did it switch from positive to negative or negative to positive as you go all the way across the problem. So we started negative, right? Did it change? No. Did it change? Yes. 1. Did it change? No. So it only changed once. So I put a 1 there. Now, when you go straight down, what was the rule that I said earlier? What do you have to subtract? 2's. Well, you can't go into the negative numbers. That doesn't make any sense. You can't have negative numbers, right? That doesn't make sense. So, since there's no other option, I can't subtract 2. That means there is no second column here. There's no second column at all, because I can't put a number here, I can't put a negative number, that doesn't make any sense for options. So, what would this last imaginary column be, if they had added to be 3? That's your combination of numbers that will work. Look at my final answer. How many numbers were positive, how many were negative? 2 and 1. It works. It's the stupidest thing in the world, but it guarantees what you should be looking for. Now, why this like influences my decisions? Like what I was saying, like this is something I do before I start checking for possible rational roots. Because if I know that that's my combination that works, that's what my roots will be. Which column has more numbers? Like when you look at those 3 columns. Positives. I'm checking positives first. There's potential that there's 2. There's more positives than there are negatives. I'll be wasting more time doing negatives. I'll have to check more numbers. 2 positives will work, in theory. So that means there's more options. So I might get lucky right off the bat, and I don't have to waste time. There's more of them. So it eliminates my workload. Literally cuts my work in half knowing that there's 2 of them. Okay, questions at all about this? Now I know it's your first attempt at seeing that. How many people, raise your hand if you've actually done that before? Oh, good, so you have seen it in Algebra 2. Okay, it's called Descartes' rule of sign. René Descartes, a French mathematician, he's like 16th century. René Descartes was, that process he made for this, he was the one who created the graph system, the coordinate plane system, back in the 16th century, the XY plane. So he's kind of a big deal in math. But this is his system for when he was checking roots back in 1500s. That was insane to me, but he could do it back then.
So like the people that created math, I think they just sat there and just played with numbers for fun.
Oh yeah, they're just
Something
ardents. They're just, just scholars they're just in it like, I would just assume they're just, always working together, trying to figure out different ways to do it and what's its uses. So, there's probably some practicality to what they were doing back then, but yeah, to me, like, not having a modern day graphing calculator, not having like a calculator to check roots and to find square roots and find decimals, they're really accurate, which is really crazy to me.
So like, just do stuff by looking at stars and stuff. So you
Yeah.
check
What about
stars.
abacus?
Yeah, abacus, yeah. I had to learn how to use an abacus in college, yeah.
I
But-
just get so confused how they come up with all the crazy things, like just looking at that, like who thought that like taking 2 times pi times half the distance around the circle would equal all the way around?
Yeah, it's kind of a weird way to do it.
Like, did you just sit there and type in whatever numbers you could until you got the right answer?
Well, they just
Made
type
it
that,
up.
Well, not type it, but like.
Yeah.
You know what's
We probably like.
Yeah.
took
But-
everything was
Okay,
made
that's
up.
it for today. I'm gonna give you the rest of the time. You have about 10 minutes or so. You can work on your 1 assignment, 5 problems. We might review this tomorrow like one more time, just to show you. But remember, tomorrow I wanna start reviewing for the test. So that's kinda what I wanna do. I wanna hand out your practice guide, test, tentatively next Tuesday for us. So that's what I wanna do tomorrow. But I'm gonna give you the rest of the time today.
What's this do?
What? That assignment is due tomorrow. Your 5 problems or 6, whatever it is.
Metal.